Hello, let's talk about running the CornerStone software. You've downloaded the program from the web. On the first time you installed it, it's going to put a icon on the desktop. It will also run the program for the first time. So this one, it's got on our desktop. Let's start from here. There's a splash screen while the program is loading in behind it. It's a nice CornerStone wall there. This gives you the option. The analysis mode is two-dimensional. You get a wall height, a wall depth, and individual sections. That's what a lot of engineers like to do is they'll draw their own walls up, design it section by section and design it. Or the analysis mode is where you put in X coordinates and top of wall and bottom of wall, and it's going to draw up the whole wall. So you've got a wall that's 100 feet long. It varies from 5 to 15 feet. It's going to give you a total block count. It's going through and design each section of the wall to give you grid layout, grid count, and it produces an AutoCAD drawing ready to go to construction that you can update it. But today, let's look at the analysis side of the program. This will be like the first time that you run the program. So it's going to expire 12/31/18. The software expires every year, so you get an update, get the new version. We're going to come in. This is just text up here to tell you what the project is. So we can just call it a title project, my initial site location, Minneapolis. We'll just leave that. Now we go into the block properties. The second one here, you've got an option of CornerStone or Magnum Stone. CornerStone, these are 8-inch high, 18-inch wide, 1 foot or 2 foot deep, dry cast units, segmental retaining walls. And we've got, the CornerStone 200, which is the long unit. We've got units for Australia. We've got permeable units in which we use a no-fines concrete behind the unit, positive connection, and these are some landscape blocks, the forest, the frogs, so the stone ledge and mirror stone. Or if we want to do a project with the bigger units, the Magnum Stone, we're not updating the photo over here, but the Magnum Stone is, there we go. Magnum Stone is a wet cast product. It's 4 foot wide, 2 feet high, 2 feet from face to tail. Interlocks with the unit below it with these secure lugs on the bottom of the unit. So we go to the Magnum Stone. These are for reinforced walls, MSE. If we go the Magnum Stone All, then that has gravity walls, the Magnum Stone Standard, the 24-inch deep unit, all the way up to a unit that's 216 inches deep for gravity walls. Gravity wall is only the gravity section, doesn't include any reinforcing. The positive connection. We've also got an option for solid units and a stone matrix. Stone matrix is a wet cast block that is 6 inches high unit. I don't really have a picture over here, but that's a wet cast product also. So let's go to Magnum Stone All. Well, let's go to CornerStone. That's probably the product that's used the most. So we'll go CornerStone 100. We check our cap unit. We check the CornerStone 100. That's this product here. We check our reinforcing type. This time we'll use Stratagrid. We could use Marify, SRW products, Centene. First time you're going to check it, it's probably going to give you an error message that there's no grid selected like this. No primary grid selected. It's going to take you to another screen. It's going to take you down here to the GeoGrid properties screen. And we're going to pick our primary reinforcement. And we'll call it a 3XT today. So if you look up here, there's a strength of 2, 3, 5 XT. 3XT is 3,500 pounds per foot. Peak strength, ultimate strength, the 1.45 creep reduction factor. Durability reduction, installation damage. So we have a working strength, long-term design strength of 2,090 pounds per foot. If we look down here, this is our connection table. If we plot all the connections, 3xt is the blue line. So it's coming right up the middle here, and it peaks out at about 2230 pounds per foot. The 10xt is a much stronger product, and you can see it's got a peak strength up here around 3400 pounds per foot. With that, block properties, this is all picked. We pick a geometry. We want to do a 10-foot high wall. The screen updating here. So we want to do a 10-foot high wall. The unit has a 4.5 degree batter. We're going to embed it 6 inches. Our leveling pad is 6 inches thick. We don't have any slope above the wall. We don't have any loads behind the wall, live load or dead load. We don't have any toe slope behind it. We look at our soils. We're going to go conservative here. We're going to say we have a silty sand, a feet 28, no cohesion, 120 pounds per cubic foot, crushed stone leveling pad. If you're on the West Coast, you may want to look at seismic. Most people don't. With that, now we look at a reinforced design. And there's our section. It's going to space the grids 2 feet apart. The minimum length is 60% of the overall wall height. This one is 80%. The reason is up here, if we go and look in preferences, what I've got checked is make all grids the same length. So that upper grid has got to be 1 foot beyond the failure plane. It extends that and then extends all the other units the same. We come back, we can look at it in static results. That's what our answer was, or we can look at it in geometry. So that's make all the grids the same length. If I do another reinforced design, you see it's going to shorten up the bottom grids down to 6 feet, and then it extends the top 2 beyond the failure plane. So a lot less excavation by going to this route. I find it a little hard to build, making the top grids longer. If I wanted to, I can click on the bottom row, and I can say, let's make all the grids the same length. Doing a Shift L. It updates everything to the same length. And what you see over here is a yellow flag, which means the geogrid did not go past the upper 2 grids. So that's a warning. That's showing you that you don't conform to the NCMA design standard 1 foot beyond the failure plane. But I don't have a lot of problem with it, because if I look at the factor safety of pullout, of total pullout, which is there's my failure plane, there's my earth pressure wedge in here pushing forward. I've got this grid, that grid, this one, and this one, as well as base friction resisting the force behind it. So are the grids going to pull out? Probably not. I've got a total pull-out capacity of 5,200 pounds per foot, or a factor safety of 3.42. So in most cases, I'll leave the grid shorter. By engineering judgment, this wall is going to perform well. Just a quick note on this page. We're up here. You want to get rid of that bottom grid. What we can do is hit the delete button. It will delete the bottom layer. It will update the calculations. I've got 4 spaces, which is too much, so I can move the grids down. Update the calculations. This will pass. Maximum 2 block spacing, 2 times 2 foot spacing, 2 times the depth of the block. 3 down from the top, 3 up from the bottom. You know, it'll work. The other way, a little bit more conservative way to do it, is maybe move all the grids down. So we're 2 blocks off the bottom. Hit the wrong button. Let's put that back up. Let's move all the grids down. There we go. So we're 2 off the bottom. 3, 3, 3. And then at the top, I hit the insert key and move it up and that's my preferred design. A grid 2 blocks off the bottom, a grid 2 blocks off the top, and then a maximum of 3 block spacing in between. Just to update, if we go back to the geometry screen, down here in this lower left corner, our maximum length to height ratio is 60%, minimum length to geogrid is 4 feet, maximum grid spacing is 2.67. It doesn't matter. The program will only space the grids at 2 times the depth of the block, or 2 feet in this case. The batter, like I said, is programmed into it. That's fixed for the product. Lab load, dead loads. If you want to put a slope on top of it, loads behind it, you can do that. Hit the reinforced calculations. It gives you your design. If you want to go back to block reinforcement, we can look at the Magnum Stone. If you're interested in a wet cast product, the bigger, I'll choose Magnum Stone All. And I'm going to run that same 10-foot design. So we're loading all the connection curves, all the block data here. That's why it's taking a little longer to update. Here's everything back. We can use StrataGrid reinforcement. And I'll go with a cap unit, a standard, 48, 72, 96, and a 120. So those are good designed with it. If I go back to geometry, I've got that same 10-foot height. Now, with Magnum Stone, you've got a choice of a 1-inch setback or a 2-inch setback. The standard is the 2-inch. If I do a reinforced design on that, whoop, no unit with reinforcing. I didn't pick a grid. Got a block reinforcement. Oh, we updated. I'll pick StrataGrid. It changed when I changed these numbers. So now we do that reinforced design. And there's a Magnum Stone. Again, our bottom grids are shorter, our top grids are longer. We're 60% from the face of the unit coming back. The maximum spacing between geogrids per federal highways per NCMA is 36 inches maximum. Since these are 2-foot high units, we're going to have a layer grid every block. And you see the tensions are T allowable. The tensions, the T max, they're pretty low in here. So that's a good design. Now, if we wanted to say, okay, let's see what that would be as a gravity wall design. Yeah, I'm tight on space. If we come in with a gravity section, we get down to 48 inch. I've got 3 48s, 2 standards up here. Our factor of safety of overturning is 1.85. Sliding is 1.76, 1.56 at the bottom of the leveling pad. And our bearing is 2,000 pounds per foot. And I said my Q ultimate is 2192. What you're going to find with these larger units, the small footprint, is bearing capacity goes up pretty quick. We could also say maybe with the larger units, I'll use 1 foot of embedment instead of 6 inches. We can update that design quickly. And with a little bit deeper embedment, I get a better bearing capacity. Yeah, I'm up to 2,600 because I'm deeper in the ground, a little bit more embedded, 10 foot to the top. And if we look on our geometry page, we got 9 feet exposed. The last thing we do to finish up, we always look at global stability, whether we're looking at a SRW, the CornerStone, or we're looking at a Magnum Stone. Just do a quick check on global. There it is. We hit global stability. We want to see a factor of safety of 1.3 or higher. I've got a 1.40. The design is good. So if that's what you're looking for, the design is done. If you want to go CornerStone, that design is done also. We do a quick printout. Print design. Print a long printout. The short printout's 2 pages. We'll do to a PDF file. Here's a print preview. There's a section. There's all of our input data. The next page, there's our results. Here's all our factor safety, overturning, sliding, our T max values, and that's a gravity wall. And then the next page is going to show us our global and compound stability 1.40. We go to the next page. There's the output. There's the factor of safety for all these different curves. Now beyond this, there's about 10 pages of hand calcs. Structural properties of the block, force details, earth pressures, total forces, space sliding, overturning, eccentricity, and bearing. Gives you all the information you need for design. If you have any questions, give me a call, send me an email. If you look under the About screen, it's Robert Race. I'm out of Minneapolis. There's my email at the top of the page. Thanks a lot.